You're listening to MedX, the Medical Extrusion Podcast, presented by U.S. Extruders. Extrude with confidence, custom extrusion equipment designed for you and your application.
Welcome back to the MedX Podcast. In today's episode, we're very excited to host Nick Zabobini and Jay Vinson, the co-founders of Symmetry Laser. Symmetry Laser is trailblazing the art of precision laser cutting and welding of hypotubes. Their custom-built laser equipment and their software-driven facility ensure high-quality, high-volume production of parts as well as the delivery of prototype parts within 3 to 5 days. I hope you enjoy. Nick and Jay, hey, thanks for carving out some time to join us on the MedX Podcast today.
Great. Thanks, Steve. Glad to be here.
Happy to be here.
Great. I'm looking forward to this conversation. We have some good topics to discuss about building a business and, of course, complex laser cut hypotubes. Guys, to start off, I'd like to hear the story behind Symmetry Laser and why and how you got started in the first place.
Yeah, Nick and I had always wanted to start a business together. Obviously, we wanted to do it in the med tech space and specifically in laser cutting, but we just didn't feel like innovation was progressing the way that it should be. And we felt that we could add something to it. So we knew we could do it. We knew we had to do it from the ground up. In order to get there, we had to build custom equipment, unique custom equipment. We had to build custom software to drive everything within the facility. And then we also had to hire the right team, build a great culture, and to hire a great team. We started out in the garage as we built out our space. The space is built, on lean manufacturing principles. And while we're in the garage, we built out the space, and then we moved here and into the space now, and here we are.
There's a lot of stories of entrepreneurial type people with ideas starting out in their garages in Northern California. So hopefully that you have some of the same success that others have had, grinding and putting all that time and effort and doing the same thing. So
yeah.
Great. Thanks for sharing that with us.
Of course.
When I think about startups and new organizations in med tech contract manufacturing, the model typically is to get your foot in the door early on in prototypes and R&D. So the ability to be nimble and provide quick turn prototypes, whether it's medical extrusions or whatever, in 3 to 5 days, so that when a program, 1 in 30, 1 in 50 go from prototype to actually V&V and production, that's kind of the model to get your foot in the door on the front end. It's interesting to me that you guys started the company from the ground up, really with a focus on production, and then also the ability to support, quick turn prototypes. So tell us a little bit about how you did that and what tools and culture and leadership and folks that you put in place to support that model.
Yeah. I mean, that's definitely the way we wanted to go with it. High volume production for us was going to be the first and foremost area that we would attack. But in order to do that, this facility that we're in, was a cold shell. We built it from the ground up. So, the FedEx driver takes 9 steps, drops the material off, material is inspected, goes on the rack. It's close to the laser system, so then gets cleaned and inspected before making its way back out the door. So we knew that the facility had to be lean, minimizing waste wherever we could find it. That was one thing that we knew we'd have to have in order to make that work. Getting jobs to the floor quickly. I know Nick can talk a little bit more about the paperless manufacturing system. Getting jobs to the floor quickly. Also being able to have production and prototype jobs running on the same machines. That's part back to the custom equipment, making sure that every machine is the same. So, high level, that was kind of the reasoning and why we did that.
Okay. What kind of tools, automation or data collection do you have in place to kind of support that?
Yeah. So, instead of like the traditional paper traveler that gets issued to the floor, everybody gets an iPad and every job is controlled through a custom software. So whether it's you're sending in an RFQ to we're inspecting parts on the floor, we're inspecting parts in final inspection, to even creating shipping labels, all comes out of the same piece of software. And it really streamlines everything. So, whether you want 15 parts today Or then Steve, in 3 months, you call me and say, hey, those parts are awesome. We need 500 parts. All the setup parameters are captured. So the machine gets set up identically. The laser parameters are all stored. So after we've made the parts once, we have the recipe to success baked in, and we can pull it up, with a couple clicks, and we're off to the races. I think that's huge. We have every process input in the facility is monitored and tracked down to the second. So if you wanted to know what the process inputs were when your job was cutting, we have all that data stored in a database. We can recall it anytime we want.
So that's all part of the lean manufacturing process.
Yeah. So instead of, we've all seen it. I was probably the worst offender with the paper traveler. You get kind of signed off, you take a cup of coffee, you set it on it, gets a coffee ring on it. Wanted to eliminate the wasted time going through all that. So everything is, in that software on the technician's iPad, so they can open it up, pull up the job, see the inspection items they need to do. We can see exactly what process it's going to next. And we have dashboards all over the shop that kind of track every job from process to process or work center to work center, so that you don't have any jobs fall through the cracks and get lost in limbo.
Interesting. Nick, while I have you, starting a business is a lot of work, a lot of time and effort, ups and downs, late nights. And I know that you have an athletic career, high school and college. You competed at a very high level in water polo, right? At Loyola Marymount University. I'm just curious, the work ethic, the competitive nature, the physical, the mental toughness that's required to compete at a high level. How has that helped you, if at all, at becoming an entrepreneur and helping to start Symmetry Laser?
Yeah, Steve, going to school and getting a degree in electrical engineering, and then having 4 hours of just, practice every day that's physically draining, kind of makes everything else going forward not that bad. Because if you're staying up till 12 or 1 a.m. working on something, but you've physically drained yourself before, you got to find a way to kind of grind through it. And so that really helped prepare me for, everything going forward to start a business and what it would take.
Excellent. Very interesting. Guys, how have you structured Symmetry Laser to be different from what most folks think of when they think of a med tech contract manufacturer? What are you doing? How are you disrupting the industry?
Yeah, Steve, I think you touched on a little bit earlier. We started with production as a focus from the get-go versus just focusing on prototypes. And what that really did was it forced us to build all the systems and structure and, the team to be in place to do that. So we touched on the custom software. Normally you wouldn't devote that much time and effort and money to build custom software that can scale to be doing, hundreds of thousands of parts a month and still running prototypes in 3 to 5 days. We touched on kind of the custom facility being built from the ground up. Everything's structured in tight functional loops. So it isn't, you process the parts here and then they go all the way across the building and then they come all the way back and they go all the way over here. It's, you do parts here and they go here and they go here and they go here. And as we continue to scale, you keep building those loops and everything stays tight and you pack it in, as tightly as possible. And so then now you have a really lean and efficient process. And when you multiply that out, you're multiplying lean and efficient versus spacing everything out in a 20 or 50,000 square foot building. And now you got to try and figure out how to do line moves and pack it all back in. How, I think another big piece for us is we have engineers. We don't have like a production engineer and a prototype engineer. We just have, one group of engineers, and they're tasked with helping customers design parts, doing R&D work, building new equipment. And they're also tasked with scaling production lines and doing the whole manufacturing piece. Mm-hmm. Well, that really opens up is now you have an R&D engineer who knows what it takes to scale parts and knows what a program looks like when it's doing 50,000 parts a month, and they can bake the DFM in, to the get-go. So now you're getting, design support and DFM at the same time, which we found is pretty uncommon.
Yeah. And just to add to that, I think almost like a model where Chamfer is trying to make it easier on engineers to buy different items online quickly. We wanted to make it easy on engineers that were tasked with a laser cut hypotube. So we wanted to make it easy for the experts in laser cutting. They send us a print, we cut them parts, we send them parts. But for the folks that need a little bit more help, we wanted to make it easy for them, not intimidating like so many things are in life. So make it easy for them to get from an idea. They have a bend radius, they have a torque requirement, pushability. They know their tube size or an estimated tube size. We have 400 standard gauge sizes here in stock. So we could just help them from the get-go and make it easy for them. One of the things that differentiates us is we're giving DFM advice or DFM comments right from the get-go. So we're always thinking ahead. We're always thinking about production and high volume, because who's been down that path? I mean, everybody has. You make this part or you have a print and it's just not scalable. It's not manufacturable. So we really focus on maybe getting a part in their hands that we know that if they say, hey, we need 5,000 parts a month, we know that we can do it. So
okay, great. Guys, let's talk about laser cut hypotubes. So for complex delivery systems, catheters, there's a lot of options for the reinforcement or the backbone, right? Braid reinforcements, coils, combination braid coils, laser cut hypotubes, and we're seeing for modern delivery systems that need torqueability, preventing ovalization, all these things that we see a laser cut hypotube from a performance standpoint is really just kicking butt these days, right? Where are we on the maturity curve for laser cut hypotubes compared to the other reinforcements that I mentioned?
Yeah, I think obviously the idea of laser cut hypotubes, that's been around for a long time. It's always tended to be price prohibitive. The braided shaft always seemed to get it on price. And we know that the braided shaft will always be around. There's always some great options and great reasons to have a braided shaft. When you need a variable flex, the long, thin wall metal shaft, now that the price has come down, just to advancements in so many areas, now that the price has come down and you have so many design options, you maximize that ID, and that's what everybody's looking for. So basically now with the price coming down, the design options, high quality, and the speed of these parts in people's hands, it's become a lot more palatable, a lot more interesting.
Okay. Yeah, you mentioned profile. Profile is king, right? So any opportunity to increase the real estate inside the lumen for devices, wires, fluids is an advantage.
Yeah. And Steve, one thing that we found is instead of trying to control the flexibility of the finished device with the jacket and liner material and maybe end up with 5 or 6 or 10 different durometer materials on the outside, you can really let the laser cut hypotube dictate your flexibility profile, and it's revolutionizing the layup process. Instead of having a whole bunch of different durometer jackets, now you can go to 1 or 2 different jackets, and all of a sudden catheter manufacturing is becoming a whole lot simpler and way more streamlined.
That's a great point, and probably a big opportunity for cost savings. Instead of starting from 72D, going all the way down to 25D or something, multiple durometers, maybe even having a single jacket over the outside, because the hypotube's doing all the work in that regard, right?
Yep. Yeah. And it also increases your yields quite a bit. Now you don't have any issues where maybe the operator didn't trim it, or you don't have to go back and rework some of those blended sections as well.
Is there, and we're going to get into some of the details about different types of cut patterns, but we can address it now or after. But curious, since we're talking about outside jackets over a hypotube, is there a kind of a limit with wall thickness in that after your reflow, you have too much material within the interstices of the cut pattern, which could prohibit flexibility, for instance? Is there a rule of thumb in that regard for the outside jacket material?
There's definitely some nuances in how you do the layup process, right?
Okay.
So I wouldn't say there's a limit in jacket material, but how much you reflow the jacket to the liner through the cuts will definitely affect the performance. And what we found out is because we're just focusing on the laser cut hypotube, we don't have a ton of process knowledge on the reflow part, but everybody seems to have different results based off of their process parameters. So some people can reflow 72D and have minimal effects. And some people say oh, this is making my part way stiffer. Let's accommodate for it in the laser cut.
Okay. Let's talk about some different laser cut pattern designs, and if you can kind of walk us through, for instance, a steerable kind of directional design, and then also like a universal omnidirectional design, if you can.
Yeah, what we found is instead of, okay, you touched on really like doing a kind of combo where it's a coil and then a braid on the back end. You can do a steerable on the distal tip and a universal profile or universal pattern on the back end. And now you have one monolithic reinforcement layer. So like a couple different steerable designs. We call them dog bones or hybrid dog bones. They look like a football or interlaced hockey sticks. And then we also have a pattern we go to quite often. We call it a monolithic ball and socket. So instead of having a ball and socket that's interlinked and the only thing that's keeping them together is interference of the tube, you actually have a monolithic structure. So you get the benefits of having that, but you also get the benefits of the ball and socket and the flexure. These allow engineers to come up with patterns that can steer, and you can put 2, 3, 4, 5 pull wires, depending on how many different steering planes you're trying to do, but you get to anywhere in the body now with them.
And some of these cut patterns are very intricate. And I was just curious how challenging it is, and how do you inspect some of those intricate cut patterns?
Yeah, it's definitely a conversation that you have to have with the customer. What is your key feature here? And functionally, what are you trying to guarantee? All of our parts are visually inspected, but then it's the dimensional inspection. So like for a steerable dog bone pattern, we would inspect kind of we call it the belly width, or the zone that's cut away, so that when it bends and it closes down, that's what's going to zero. So that's really what's dictating the ultimate bend radius. Unlike a universal flex pattern, we find most people are ending up with an interrupted spiral pattern. It's the most cost efficient, and it gives you the most customization and flexibility in your design. And so for that, we can measure the pitch, which is the spacing between the cuts down the axis of the tube. You can measure the degrees cut and the degrees uncut, which dictates how much torque can be transmitted by the tube and the tensile strength of the tube, and has a pretty big play on flexibility as well.
And to touch on what Nick is saying too, obviously if you have a 40-inch long shaft, people are going to always be concerned about price. And so we push people towards, you don't have to spiral on the proximal end. If you can get away with that, that's the way we go, because we'll save cutting time, save the customer money. Yeah. And on the distal end, that's obviously sometimes where you'll have to pick another pattern to get where you need to go. But just something that we're always thinking about as part of that DFM.
Right. Interesting. I noticed, I saw your deck and on your site, it talked about custom designed fiber lasers. And I was just curious, why fiber, not femtosecond?
Yeah, when we looked at it, femtosecond lasers are really cool and the technology is awesome. But what we came to the conclusion, femtosecond lasers are perfect for heart valve frames or self-expanding stents, where the part's relatively short and you can afford to cut at a snail's pace. Mm-hmm. Essentially, femtosecond's cold machining or athermal ablation. So if you start processing with any speed, it all of a sudden becomes a thermal process, and you're no better than you are with a fiber laser. So fiber lasers have been around for a long time. The reliability on them is unsurpassed. We have lasers that'll run for 20,000 hours at max output and less than 2% power degradation over that life. So that's pretty incredible.
Yeah.
I think the big thing too for us is we operate at the bottom of that power band too. So we're not even pushing these lasers. So our lasers will run for a decade and we won't see any power degradation across them at all. So that's really allowed us to, you have a super reliable laser. It doesn't change at all. You can stack them up down the line and they're all going to perform identically to each other. And so that really helps provide scale and consistency, part to part, machine to machine, and you know what you're going to get every single time.
Yeah. And then the obviously cleaning portion of it, we knew that had to be robust, and we take a lot of pride in that part of it too, because we have to clean out that oxidized metal. We felt that when you have the two options, the fiber laser is a clear advantage for what we were trying to do.
Okay. Speaking of some of the post-processing activities, what can you share about the value chain that you offer there as far as what you do in-house and the partners that you've selected for certain activities or processes?
Yeah, sure. So as we kind of mentioned earlier, we're just cutting, cleaning, and inspecting parts here. We obviously have our own custom equipment. We also have some laser welding equipment that we built up. But if we do need EP, EDM, some other items that we need to send out, we'll send them to our partners that share the same vision as us.
Mm-hmm.
So they're quick turn on the prototype side. They have the ability to scale as well. But we've been able to hand select those partners, and it's been obviously really helpful for us. So we'll manage that for the customer. They'll send us parts in.
Mm-hmm.
If the parts have to go out, they'll go out, they'll come back, we'll inspect them here, and then they'll ship out.
Okay. So you manage that whole process for the customer. Interesting. All right.
Yeah, the goal is to make it seamless and super easy for the customer.
Yep.
And then the post-processing parts we have in-house, Jay touched on it. We clean all of our parts to ASTM A380 in-house. We also have nitric tube passivation for the customers who want their parts passivated. And then, we send a lot of welding work out, but we also built up some custom welding systems for some certain business cases where it made sense to do the welding in-house.
Okay. In some cases, you can do laser welding in-house.
Correct.
Gotcha. Okay. Recently, I saw within the last couple of weeks, I believe, on Chamfer, on the LinkedIn, that you've had added components and parts to the online store at Chamfer. So congratulations on that. And what can you tell us about that? What you're offering there for quick turn?
Yeah, we added over 220 SKUs total, 6-inch lengths, various pitch profiles, various tube sizes, and just wanted to make it easy for somebody to pick those up on Chamfer, get them in their hands, and then maybe start the process of, hey, we need a custom tube and a custom profile. We thought that was a good way to get out and allow the customer to see our parts quickly. And then I just thought it was a great spot. We love working with Chamfer, and it's a great location, a one-stop shop for engineers to go source everything medical. That was the reasoning behind that. So it was just pretty recent. And so far, it's so good. So
good. Yeah, great group over there. And they're adding new partners all the time. And it was good to see you guys join Chamfer. I'm pretty close to those folks.
Yeah, great. Yeah, they're great.
Yeah. Guys, this has been an interesting conversation. I really appreciate you walking us through, how you started and where you are today, and all the great work you're doing and going through the different cut patterns of hypotubes. And, the maturity of laser cut hypotubes. There's a lot of talk and a lot of use, certainly for these more modern applications, left side of the heart, transeptal, where you need steerability and torqueability. So good job there, and really appreciate your time.
Yeah.
Yeah. Thanks, Steve.
Thanks, Steve. See you soon.
All right. Thanks.
Thank you for listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. For video episodes, go to us-extruders.com/podcasts. All links are available in the show notes.